Hello, thank you for joining today's webinar. Load balancing, why you need to get DevOps and NetOps on the same page. My name is Rochelle Wheeler, and I am joined today by Morris McMillan. Before we begin, I'd like to cover a few housekeeping items. There is a questions panel located in the upper right corner of your screen. You may need to expand that panel by either clicking the plus sign or the down arrow to see a full view. We will take questions at the end of this presentation. You are encouraged to submit those questions via the questions panel at any time. Today's session is being recorded, and the recording will be made available at the conclusion, along with a copy of the EMA report entitled How to Succeed with Load Balancing in a Hybrid Multi-Cloud World. I will now hand today's presentation over to Morris McMillan. Morris?
Thank you very much, Rochelle. Good morning, good day, good evening to everybody. My name is Morris McMullen. I'm a product manager with Progress with responsibility for the Kemp Loadmaster. And today we're going to look at how DevOps and NetOps can get aligned or should get aligned. And the background to that, we'll be looking at the EMA report, that the research report that has prompted this, some of the problems identified out of that, and how we can go about getting started on getting that alignment of DevOps and NetOps and load balancing. So firstly, if we look at the EMA report, our topic has been inspired by a piece of research that we got done by Enterprise Management Associates on load balancing, how to succeed in a hybrid multi-cloud world. And this research dug into how organizations manage and operate their load balancing assets. And it, along the way, uncovered some interesting insights on particularly that part of how DevOps and NetOps teams are operating independently, how they interact with each other. We will be providing each attendee with a copy of the report. It all covers many topics in there, and it provides a roadmap for load balancing success. But today we're going to be concentrating on that DevOps, NetOps silos, how we can break those down. So one of the first questions that we asked there was, who owns a load balancer? And the research came back and we saw that half the organizations have centralized ownership of their load balancing assets. And this seems to be the best practice in there. The ownership is shared between DevOps, NetOps, potentially security teams in there as well. However, as we drill down a bit into the report in a bit more detail, EMA suspects that there's a bit more fragmentation of ownership there than that data reveals. Like, for example, smaller mid-market organizations with between 1,000, 3,000 employees are more likely to have a siloed approach. And respondents who identify themselves as we work in DevOps, they're more likely, actually at 75%, to report a completely siloed approach to load balancing. And that's suggesting that DevOps groups are often using their own load balancing that other groups aren't aware of, for developing, deploying, applications. And often then maybe it's a case of, once they roll the applications into production, into, hybrid cloud environment or whatever, the infrastructure or NetOps team or security teams, may get them to change. But it's interesting that the DevOps see themselves as having more control. And you can see there a problem emerging that, potentially there'd be delays in getting new applications deployed because DevOps are planning one thing, NetOps are thinking something else, and we need to get those two teams aligned on the best way forward on uh, actually delivering the application. Some of the problems identified in the report with the siloing of the the uh, the different groups, the big one there we can see is inefficiency, and this inefficiency can be as simple as who is responsible for what, or the complexity of ensuring that changes made by one group don't impact another. And like the network team, let's say, and I'd include the security team there, would have traditionally been focused on network availability and security, keeping the lights on, getting as many nines uptimes as possible to protect the network, and don't really see the application as such. They don't necessarily understand what the application requirements may be. And while they might use automation and infrastructure as code, repos, the cultural mindset would still be very much there to proceed with caution. And this is often where you get the conflict, and DevOps and NetOps need to get aligned to where both groups have a cultural and technical exchange, and that's important that the cultural part is in there as well, where there's unified and shared approach to deliver better agility, better efficiency around network application changes, all of those things happening efficiently. Uh, Another point that comes out of this here is on the inefficiency around fragmentation of tools and technology. Uh, in the report, it looks at this from a multi cloud, hybrid cloud data center, so many delivery points. It looks at it from that point of view, and it finds that 57% of respondents use virtualized load balancers from their traditional on-premise vendors rather than cloud native solutions. And this is part of that workaround of avoiding using multiple load balancing solutions from the cloud, because they increase the complexity and operational efficiency if you've got multiple different cloud vendor application delivery infrastructures to support. So having that unified application delivery approach based on the same vendor for on-prem and cloud, it all not only helps in that efficiency part, but also that second point around visibility, being able to see everything, being able to see across multiple environments. For example, if you've got an API gateway running in Azure and it's serving applications, aggregating application APIs from Azure, potentially from AWS, it can provide you with end-to-end visibility on things like that. And we have the challenge there that the groups will, they'll have a different lens to which they'll view the environment, and the tool sets that they use to view that lens. And again, fragmentation of the roles means that that end-to-end visibility across the whole infrastructure may be missing. And as we go down the list, you can see lots of other problems: performance, security, compliance, and we need to really look at how we can get some of these problems solved, being able to address all these things to make number one, getting these problems solved by getting your groups aligned. So one of the areas that as we go through the report, we see that the issue is, big issue here is culture. You have an issue here with getting these groups aligned culturally, but underlying that, there are some technologies. The culture bit is, beyond my scope in terms of what I can talk about here today, but it can delve into looking at the pivotal role that selecting the right load balancer strategy can play in making it easier for your teams to get aligned. So just some background information here coming from the analysis of the EMA report. Aside from operational inefficiency costs, a multi-cloud approach using the native load balancer in the cloud can be much more expensive, than using a virtual load balancer from a vendor. It's things like it's the fragmentation of the purchasing power. Each individual DevOps team having the transacting individually with these different providers and not getting the benefits of the scale of the purchasing power of your organization, and again potentially leading to cloud services sprawl around there. But some of the other things in there as well is the 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 unplanned costs that potentially somebody in a DevOps role may not see. It's like pay-per-use features, for example. Some cloud providers may charge additional for features such as, let's say, something like WAF rules. The more WAF rules you've in, the more you have to pay. Sometimes it may be something like every time you deliver a CAPTCHA authentication, that's another cost point. And while you may be buying them in thousands off per units or whatever, that can build up in cost, and it's the unpredictability of it. Understanding the cloud cost is challenging. They use multiple different metrics on different platforms to deliver the cost, and a small change in something like that there can lead to a significant spike in costs. And this is where, let's say, using a traditional virtualized load balancer from your traditional load balancing vendor, this is where it comes into its own, because the only metric there is throughput. Run as much as you want off all the services. You're not getting metered on the usage of a feature within the product. And you also have if you're dealing with one vendor, you've got economies of scale there in terms of leveraging things like pool licensing, for example, getting the best price, etc. And across our things, and the standardization of the vendor makes it easier for you to understand your cost base as well. The cloud costs are very difficult to understand when it comes to load balancing. So one of the other questions here is around looking at the cloud environment is some of the problem areas highlighted in the reports. The challenges with scaling and performance. It seems to be a challenge there, and again, the fragmentation of responsibilities between your DevOps team and your NetOps teams will magnify these sort of issues as teams start finger pointing when there's an issue. Is it a problem with the way that the network is configured? Is it a problem with the application? Is it all these things? So again, that challenge with performance, scaling, etc. is significant there. If you have an integrated platform, you can integrate your teams, and the organization responsibility can the issues around that can be resolved much easier. When the teams are together, they've built this together, they've delivered this together, they've managed it together, and problem solving and the inefficiency that comes from that are minimized. Just you may notice here that I'm mentioning a lot about the cloud-based environment here. EMA associates in the report explicitly call out some of the inherent problems with cloud provider load balancing solutions, and recommend the use of virtual load balancers from a load balancing ADC vendor. And the detail in the report actually shows that many organizations already have taken this approach. Like they note that 38% of single cloud organizations are already using virtual appliances as their way, even if you're just in a single cloud. But when you move to a multi-cloud environment, you can see this number rises to 73%, where these organizations have seen we've got multiple different solutions here. We can't manage that. Let's standardize. So you can see standardization happening there. Excuse me. And we can see that that is simplifies the challenge of getting your DevOps and NetOps on the same page, on security, etc. That with one solution you can integrate all of these together. Uh, just an interesting point, just on the data there, is the lack of advanced features, and again, this is where there's you've got a complete an integrated solution that a load balancer from a traditional vendor brings you. It covers many different capabilities in there, whether that's security capabilities, whether that's being able to load balance across multiple different data centers, clouds, whatever, multi-site, multi-cloud, authentication, complex authentication, etc. It can do all of that within the box. With your cloud solutions, the lack of functionality means that you have to backfill in, the gaps there with other products to help plug that functionality gap. And again, that adds to complexity. There's more chance of introducing security holes. And again, it gives lots more opportunities for those NetOps and DevOps teams to be there with completely different tool sets, and not being connected, not being on the same page, and again, ultimately leading to challenges around when there's a problem, whose problem is it. And just looking at the impact of a siloed approach to DevOps and NetOps, if we look at how the organizations are impacted, we can see that the skills gaps are a major factor, and this is not a big surprise. If organizations have challenges hiring and retaining skilled staff across all the areas, but again, that thing about having multiple different technologies and fragmented technologies makes it much more difficult to try and integrate these two different groups if they all have to start learning multiple different platforms. Having a single platform that they can do their own role on, and also have visibility of the other roles as well, so that the DevOps people can see the NetOps, etc., all in the one place, makes it much easier to integrate that. And we can see that the conflict between the teams is quite high, and at 42%, and this is inevitable when they are working independently, have disconnected processes and systems for management and monitoring. They're going to have to learn how to work together, and a common platform helps make that much more achievable. Okay. Just looking at the stats here, you can see the poor IT leadership down there, 17.1%. That stat was skewed very strongly to DevOps teams. So not exactly sure what to make from that observation, what we can deduce from it, but it's interesting that DevOps teams see themselves as being poorly led. So how do we practically look at getting some alignment between these teams? As you mentioned, getting a common platform for application delivery, your load balancers, using the same load balancer across all your cloud properties, and even your on-premise environment, gives you that consistent API for all of the services for all these different teams. It's DevOps, it's NetOps, it's security. We keep having to bring security in because they're part of this here as well. It avoids those complexities around, the cloud fragmentation, different APIs for different things, different ways of doing things, different cost models around how uh, the the around application delivery, etc. And you've got that common skill set. You can use a common skill set across everything. So this allows you with a single interface, to define, you can, how your applications are defined. You can see their authentication policies. We can pull statistics consistently, so we've got a single source of truth. Better operational efficiency when troubleshooting. All the logs, everything. There's a consistency there that we can do, and all that allows the teams to work together because you're starting to standardize on a common set of tools to do the application delivery. It all plugs into the same environment from a monitoring point of view, into your security analysis, whatever those systems may be. And again, that gives you better end-to-end visibility, across all your cloud and on-premise environments, and a consistency there as well. Um, Closing the skills gap here is a significant part, and we can see a part of the research here was looking at some of the challenges that people have around skills. And again, if you've got multiple tools, multiple environments, that complexity leads very much to uh, having challenges around making sure everybody knows about everything, and people tend to become generalists. They know a little bit about everything, but we can uh, bring teams together, and by bringing teams together, they share their own skills, so they can, DevOps can impart those application insights to the network and security teams that they would not have visibility on beforehand, and they can do that early in the development process of an application, when it comes to the application maintenance operation, all of those things, that they're sitting closely together. They're sharing their skills on their specialist area with the other team, who then have much more insight on the challenges that the other group uh, face, and it would lead to a much better chance of success. Um, you know, a lot of these uh, skills gaps here, as I say, are something that a lot of people face, and you can see there that some of them are pretty specific, like API management. There, that is, more APIs. It's complex. Again, it makes the mountain that has to be climbed there in terms of it, understanding all the APIs much more difficult, and really, this is just a building block. Uh, Getting all your application delivery infrastructure, getting it all standardized on one application delivery controller, one set of tools, that allows you then, from an organizational point of view, to get these teams together. Because it may be difficult. They're entrenched in their own view of the world, but being able having a common platform makes it much easier to bring these teams together on a common platform, from where they can you know deploy, manage, operate their applications successfully. So that is me at the end of that there. I am just a few minutes ahead of time, and I'm just checking here to see now, have we got any questions in the okay. Question here: where can I get a copy of this report? Okay. Yeah, we mentioned. The report will be a copy of the report will be sent out in the follow-up email to all the attendees, so you'll have full access to all of that in there. Okay, and you can delve through and dig into those some of those numbers yourselves. Another question here. You mentioned the cost benefits versus using cloud provided options. Can you expand a bit more on the cost comparisons? Um, right. It's true. Comparing cloud pricing models can be, it's very difficult. It's not quite apples and oranges. Uh, but if we look at how application delivery is priced, for example, if you are on uh, AWS, they have a number of different metrics that they will measure you on, from new connections, active connections, traffic, the number of rules that you fire within a period, and based on those four metrics, it will decide whichever one is the highest. It will use that as the billing entity. So you may get billed based on your connections for 1 hour. You may get billed on your traffic for another hour. You may get billed the next hour. The billing metric may be the number of WAF rules that got fired. So it makes it very, very difficult to plan uh, the the usage. So, and even to compare to another load balancing solution. Um, so that, for example, is a challenge there. And then you look at Azure. Azure takes a excuse me, uh, a a different approach. They've got this concept of a capacity unit, and it's got a number of metrics there again that they'll start measuring. But you know, there, for example, a capacity unit is limited, I think, to about 2 megabits per second of throughput, and as your traffic goes up, it will automatically start multiplying out these uh, units for you, but also your costs are going to go up there as well. So there's very varying metrics in there, and then you find that if you want to add services like authentication, that's another cost item with a different cost metric to it as well. If you need to add web application firewall, that's generally an add-on as well. So there's loads of other sort of levers that move all the different cogs in the pricing model, so it makes it quite difficult to predict. And just look and see, is there any other questions in there? No, that's it. I can't see any more questions. So if there's no more questions, I will say thank you all for your time, and hopefully you will get some value out of the report that we're sending to you. And thank you all for attending today. Bye.